Welcome to Bladed Tech Musings, the channel dedicated to retro tech, innovation, science, and technological entertainment. The Mars Perseverance rover was lifted to space on July 30th, 2020 atop an Atlas V rocket from Cape Canaveral Air Force Station's Launch Complex 41, 3 days before the scheduled splashdown of the Demo 2 Dragon 2 manned spacecraft. The rover was sent on a nearly 7-month journey to the Red Planet, with not only the usual payload of science instruments, but a flying drone that will, if it works as designed, be the first operational aircraft deployed to another world. The rover also carries 43 tubes to hold rock and soil samples collected after Perseverance's landing. The vehicle will place the tubes on the surface of Mars for retrieval by another robotic mission, which will bring the specimens back to Earth. That mission isn't expected before 2026. If it seems like there were an unusual number of Mars missions being launched in July 2020, it isn't just your imagination. NASA's Perseverance rover is the third such mission, following the July 19, 2020 takeoff of the HOPE orbiter developed by the United Arab Emirates in partnership with scientists at 3 U.S. universities, and the July 23, 2020 launch of China's Tianwen-1 orbiter, which also has on board a lander and a rover. All 3 missions will arrive at the Red Planet in February of 2021. NASA Administrator Jim Bridenstine explained just before the Perseverance launch why it was critical to get the rover, as well as the Chinese and Arab missions, underway before August of 2020.
So look, here's the other challenging thing with Mars in general. You know, we can only go to Mars once every 26 months when when literally the planets are aligned, and if we miss this launch window, you know, it would cost us $500 million to store this vehicle for the next 2 years. And so there's a lot of reasons to go forward. Some of it is, you know, financial, the NASA budget, and then the other big reason is Americans want to see us continue to do big things. I want to be
NASA's 2 Viking landers in 1976 marked the beginning of a series of missions to explore the Mars environment and determine whether the planet's past was warmer and wetter, with possibly even rudimentary life present. Those missions didn't find any signs of life, fossilized or otherwise, but they did confirm that the Mars surface is habitable in a fashion. This was an important consideration given the upcoming manned Mars missions, tentatively slated for the 2030s. In the following segment, Deputy Project Manager Jennifer Trosper explains where the Perseverance mission fits within NASA's Mars exploration timeline.
Well, we have always been interested in Mars because it's the thing that's most like Earth that we know of. And it's a little bit different today, and so understanding what happened to Mars will help us understand more about our solar system and also more about Earth. Now, as we said, Mars exploration started in 1965 with the Mariner spacecraft flying by Mars. And in 1975, we actually landed the Viking 1 lander on the surface of Mars. And then after that, we started sending orbiters with more sophisticated instruments. Those instruments would do global mapping. They'd find the minerals. They'd find the topography of Mars. They'd actually study the weather of Mars. But we found out that those orbiters needed partners. They needed partners to go down to the surface of Mars and explore like a geologist on Earth would, where he walks around and takes pictures and maybe she takes some measurements. That's what these rovers needed to do, and that's really what started the Mars rover program for us. Our very first rover we sent in 1997, it was a Sojourner rover. Sojourner weighed about 25 pounds and drove all of about 400 feet. But she really showed us what value a rover on Mars could have. And so then the Mars program started the Follow the Water theme to try to understand Mars better. And the first 2 rovers that were sent to Mars to follow the rover were Spirit and Opportunity. They landed on opposite sides of Mars in 2004, and they drove 30 miles combined. And they both found evidence that there had been water on Mars in the past. But we still weren't sure whether that water fostered an environment that was good for life. And so then we sent Curiosity in 2012. The Curiosity rover was big, it had a big robotic arm, it had a drill, it had a science lab in the front. And Curiosity was trying to understand the habitability of Mars. Could Mars have ever fostered life? Could life have ever grown on Mars? And within months of Curiosity landing on the surface, she actually found an ancient habitable environment on Mars. But we still don't know if life ever did form on Mars, and that's the goal of the Perseverance mission.
NASA says it spent more than $2.4 billion to design, build, and prepare the Mars 2020 mission for launch. After factoring in the rover's transit time to Mars and its roughly 700-day planned operational time on the planet itself, the total mission cost is expected to be $2.7 billion. The 2,300-pound Perseverance rover is about 10 feet long, 9 feet wide, and 7 feet tall. The rover is mounted on a descent stage that has a heat shield for re-entry and a parachute that opens at an altitude of about 7 miles. Roughly 20 seconds after deploying the parachute, the heat shield at the bottom of the spacecraft will drop away, allowing a downward-facing guidance radar and cameras to start seeing the Martian surface. While the descent stage's thrusters slow the rover's speed to 0, the spacecraft will look for a safe place to land. Once the correct parameters are met, a bridle will lower the rover to the surface from a height of about 70 feet. Once the rover's wheels touch Mars, the bridle will be cut and the descent stage will fly away to crash at a safe distance. Some of the rover's mission parameters are explained in detail in the following segment.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
The Perseverance rover will land at a location called Jezero Crater. Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled. The crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
We're going to be taking microphones with us. For the first time, we're going to have that human sense on another planet.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, the name of which is now Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
So what Mars 2020 is going to do is to drill samples, put them in small tubes. We're going to seal it in its own individual tube. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
Once the rover is on Mars and powers up its science instruments, one of its first tasks will be to place the drone, called Ingenuity, onto the surface. Perseverance will release the 4-pound rotorcraft and then drive away to a distance of at least 350 feet before the helicopter flies for the first time. Ground controllers will program the helicopter to perform a series of test flights during a planned 30-day campaign, beginning with a relatively simple up and down flight lasting less than 30 seconds, and then at various distances and elevations as the drone's operational capabilities are confirmed. In this concluding segment, Drone Helicopter Project Manager Mimi Ung provides some context for the drone's mission.
Mars Helicopter Tech Demo is motivated by the potential of adding the aerial dimension to space exploration. In the future, a helicopter can serve as a scout for rovers and astronauts. A helicopter can get us to places of high scientific interest that cannot be reached today. It's not easy to build a rotorcraft for flight at Mars. The atmosphere there is very thin, about 1% compared to that at Earth. So a helicopter for Mars has to be very light and have a rotor system that can spin very fast. Behind me is the full-scale model of Mars helicopter Ingenuity. It's very light, 1.8 kilograms, about 4 pounds. It's capable of flying through the thin atmosphere of Mars and is capable of surviving and operating autonomously. There is a set of milestones between now and Ingenuity's first flight. The very first one is when we turn on the helicopter and the base station to check their health. First time operating in true space environment. The next major milestone will be when Perseverance rover deploys Ingenuity helicopter to the surface. The deployment will also mark the first moment the helicopter starts to work on its own in a standalone manner. It will never return to the rover. And the first major milestone then will be the helicopter surviving the first cold Martian night, about minus 90 degrees Celsius. And we've designed the helicopter to keep itself warm. So we've planned for up to 5 flights in the 30 Martian days that have been set aside for our flight experiments. The flight data we get from the helicopter will inform our team the health of the helicopter and performance of each flight. The data could also include a few color photos. First ever photos of Martian terrain taken from aerial vantage. That would be true icing on our cake.
What do you think of the mission objectives of the Mars Perseverance rover? Do they compare favorably with the UAE's and China's concurrent Mars missions? Share with us by dropping a comment below. We hope you enjoyed this 38th episode on the BTM channel. If so, click that like button. Not a subscriber yet? Clicking the subscribe button and the bell notification icon will help both our YouTube standing and keep you informed when new episodes are released. Links to our previous episodes can be found below. Stay connected by occasionally checking our Instagram feed, where we post content from our upcoming episodes and from episodes past that you may have missed. Make sure you follow our Twitter account, where all new episodes are announced. And finally, join us on our Facebook page, where we cover current news and events related to channel content. Thanks for watching.